Alright, in this video we will be looking at page 431, problem number 12. We are solving systems by graphing. Okay, so they give us the two equations, y equals negative 3x plus 3 and y equals x plus 1. For the sake of keeping these straight, I want to call this equation y1 and this equation y2. So, in order to graph, we know we need 2 points. I'm going to generate 2 points by hand for both of these. This will be x and y1. This will be x and y2. Alright, so for this first line, you can see that the y-intercept is 3. Slope is negative 1, y-intercept is 3. So I know this is the point 0 pairs with 3. In order to graph a line, we need one more point. I will substitute any x, say 5. Substituting 5 in place of x. Negative 5 plus 3 is a negative 2. When x is 5, y is negative 2. I will plot these 2 points coming over to my coordinate plane. Y-axis and the x-axis. Plotting 0, 3. 0, 1, 2, 3. That's my y-intercept. 5, negative 2. 1, 2, 3, 4, 5. Negative 1, 2. Oftentimes I will label those points, but we're going to have lots of things going on in this picture, so I'm not going to leave them labeled for right now, and I will use a straight edge to draw a line through these 2 points. Right. That is y1. Okay. Now, do a color change. Let's use green here for y2. This is my y2. So again, this is my y-intercept. That is the point 0, 1. Now I'm going to take any other x, say 4. Substituting 4 in place of x. When x is 4, 4 plus 1 is 5. I have 2 points. I can graph y2. 0 pairs with 1, that's here. 4 pairs with 5. 1, 2, 3, 4, up 1, 2, 3, 4, 5. Alright. There is my y2. And now I can see very distinctly we have a point of intersection. This is my point of intersection. This point here. It is the solution to the system. It is a point of intersection. It is the point over 1 up to 1, 2. And you will see this 1, 2 will indeed satisfy both of these equations. In y1, substituting 1 in place of x, negative 1 plus 3 is a positive 2. In y2, substituting 1 in place of x, 1 plus 2 is 2. So here we see in y1 we have the ordered pair 1, 2, and in y2 we have the ordered pair 1, 2. This is the only point in the whole world that both of these will have in common. Now we will show the calculator method that we saw earlier in class. We will go B for graph, selection B. I have some equations in here already. I'm going to eliminate those. Menu actions. We are now going to graph the system using our calculator. From home screen, we will first select B for graph. then menu, then 3, 2, 1, 3 graph entry edit, 2 equation, and 1 line. Now we have a choice to make. Do we want 1 for slope-intercept form or 3 for standard form? Well, we can see both of these equations are in slope-intercept form. I will select 1. Now it asks me for the parameters slope and y-intercept. Well, the first equation is negative x. That's an implied negative 1. So I key in negative 1. Then I scroll to the right. Y-intercept 3. I hit enter. There's my first line. I can see it doesn't look a lot like my line here, but it's because of the zoom. Here we have a different zoom. This is a square zoom. I can make a change and it will look similar. Menu, 4 for window, and 2 for, pardon me, I want zoom square, 4 for zoom, and then I'm scrolling up. Zoom square is B. This turns my viewing window to look like my graph here, and now I can see that this graph is identical to that one. So it was zoom and zoom square, which was zoom B from the zoom menu. Now I want my second line. Again, I go menu, 3, 2, 1, 3 for graph, 2 for equation, 1 for line. Again, I choose slope-intercept form because that's the form of our second equation, slope-intercept form. Now I want the parameters slope and y-intercept. This is an x, that is 1x, slope is 1. Y-intercept also 1. Now I hit enter. And now we can see we have exactly the same situation. Here we graphed by hand, here the calculator's graphing it. Now we want to find this point of intersection. Well, we can go menu, then 6 for analyze, and then 4 for intersection. It says lower bound. We want to move the dashed line to the left of our point of intersection. It's currently in a good location. We hit enter. Now it says upper bound. We want to move our dashed line to the right of our point of intersection. And you can see now that the gray area indeed encompasses my point of intersection. Hit enter one last time. It found our point of intersection, which you see there is 1, 2, which indeed we knew from the beginning.